Hello guys, so today we are going to be talking about a techniques of divide and conquer called binary search. So in binary search, what we're going to be doing is just searching through a list or an array of numbers using a divide and conquer. So a binary means two, so what you're going to be doing is divide the items into two and then deal with it, in a bit, and then if you're still not able to get to your solutions, you divide into two again until you eventually get to your solution. So in this case, we're going to be using divide and conquer to search through a list. So in this case, I have examples here. Supposing we have a list of numbers 1 to 10 and you're asked to search through any of the numbers. For instance, you're looking for a 4. All right, so the natural search you would do would be the linear search and trying to see start come from here and search hacks one. Are you 4? You say I'm not 4. You move on. 2, are you 4? I'm not 4 until you get to 4, right? And which will be your O of n. So binary search is O of log n, which means that you don't actually have to go through all the numbers and then you just divide it to 2. So in this case here, you have the items 1 to 10. This is just example. The first thing you're going to do when you're doing a binary search, it would be to find the index of the first number, add it to the index of the last number, and then divide it by 2. What that does is it gives you the index of the middle number. So it gives you the approximate index of the middle number, depending on whether it's odd or even you're dealing with, So if it gives you the middle number, right, the middle index, so you can then compare the number at the middle with the number you're looking for. So if you compare the number at the middle with the number you're looking for instance, I said 4. So if you compare 4 with 6, you know that 4 is less than 6. It means that you should narrow your search to numbers downward, below the middle, from the first point to the middle. You know that that's where your search is. You don't have to deal with the upper side because it doesn't belong there, because what you're looking for compared to the middle number is less. All right, so you just concentrate on the lower numbers. Now in the lower numbers, you don't begin to search again from beginning. There's no point. You would also divide the items on the at the lower part, in this case from 1 to 5. You 1 becomes your first number and 5 becomes your last number, because that's your scope of search now. So if you look at that, and if it's less than, you'll find the midpoint again. So the midpoint will be 3. So if you look at it, if it's less than the middle number, it means that you're going to go downward. If it's more than it, then you go upward. All right, you go upward. So if you go upward, if the search is between 4 and 5. So it's between 4 and 5. You have two numbers, and then you can then say, okay, their midpoint of course is 1. So when you compare this one, if it's not this, then it's going to be this, and then within the third try, you're able to get out the number you're looking for, other than you going through it one after the other, which will mean that you are going to have to try it 10 times. Imagine the number you're looking for is at the extreme end, and then when the list you're looking at is like 100, you're going to have to look through everything. So the techniques is just to divide it into 2 and then compare it with the mid number. If it's less, you go for the you limit your search to the lower scope. If it's more, then you limit your search to the upper scope. This is just an example. Now let's see how we can translate this example into a JavaScript code piece. So I have here opened and I've created this file, binary search, and I'm going to be running it with a node monitor for us to see an instant result. So let's say we create a function. So let's say function binary search, right? So the first this thing, let's say we give it the sorted array, which is the first parameter, and then the second parameter is the value. This is a choice, whichever one you want to make, the first or the second. You're free to do so. All you need to do is to know what you're doing. Now, so this is the array that I'm going to be sorting from, and then this is the value. Let's say this is the value I'm looking out for. Okay, so the first thing, like I said in that place, will be to first of all look for the first index and the last index so that you can get the midpoint, right? So the first thing will be to get the first index, and the second thing will be to get the last index. Right? So my first index, of course, will be to ab initio will be 0. So let me say I say first index will be 0, and then my last index of this is of course an array. So the last index, the last index be equals to so let me just be equals to the sorted array, which is the array dot length length minus 1. Okay, length minus 1, of course, because of the 0 index of array. So okay, so this gives me the last index, the middle index. So the next thing I'm going to do is to check, while the first index is less or equals to last index, I'm going to check through the number I'm looking for. Why the first index is less or equals to the last index, I continue to check through and do my divide and conquer. So the next thing is to do a loop, which will be while the first index, in this case, is less or equals to the last index. Okay, so what I'm going to do there is that I'm going to get the middle number, or the middle index, get the middle index, what should be, let the middle index will be equals to the first index, will be equals to the first index plus the last index divided by 2. You know, if you do this, you are going to have, sometimes you may have fraction, you know, so what you need, you want to be sure of what you're doing, so you need to round it up. So it's best you do it as floor rather than, so you say math dot floor, which take care of rounding up and rounding down of the decimal. So we have math dot floor, so we're gonna have a rounded figure, right? So like this. So the next thing I'm going to do will be to then compare what I'm looking for with the middle number. You know, since I know the midpoint of that array now, next thing will be to just compare the value I'm looking for with the value at the midpoint, right? So that's the next thing I'm going to do. So here, compare the target value with the mid value, right? So that's the next thing you're going to do, which will be if the sorted array, which is the array, then middle index. Okay, so if this is less than the value, if this is less than the value, your target value, it means that what you're looking for belongs at the top, at the, you know, upper scope. So if the middle value is less than the value you're looking for, it means that you have to look for numbers that are greater than the middle value. All right, so your first index will shift from the first value. You change your scope from the first value, your first index shifts to the middle index plus 1. So if the middle, for instance, was 5, so you start looking from 6 upward. So you have from middle index plus 1. That's where you start looking out for. So let me use the style here. Okay. So that's the point here. So you compare the target value with the middle value. So if this is this, then you look your middle. Your first point becomes the middle index plus 1, and then otherwise your last index will be, what it means is that if this is not less than this, it means that the value belongs in the lower scope, right? And then your last index that you're looking out for should be the number that is a number less than the middle index minus 1. Less than the middle index. So it goes, if for instance the middle index is 5, you start looking, the last number would now be 4. So it looks from the first number, which will be 0, to the 4, because the middle is 5. Something pretty simple and straightforward. So otherwise, this one, because it's possible that it's exactly equals to the middle number as well. So here, if the sorted array is greater than it, that's the middle number. If it is greater than the value, then you have the last index to be this, right? So otherwise, else, otherwise I'm going to have to return the middle number as you are the one I'm looking for. So if it is not less and it's not greater, then you are the number. The middle number might actually be the number you're looking for. So I will just return the middle index. So if I return the middle index as the position, so you know that the position is what we are talking about here, the position of the item that you're looking for. So you know what you're looking for, but you're just trying to look for which position is it in the array. You know what you're looking for. You're looking for its position in the array. So if it is not in the array, you are going to have to put otherwise. It's just like some of you knows JavaScript. You say you are looking for last index of, or something like that. So if it's found, it returns its position. Otherwise, it returns -1. So that if it is not found, it returns something -1, right? So if anyone is using your algorithm to search through a tree, or to search through a linear array, if it's not found, it returns -1. If it's found, it returns its position. Pretty much like how index of work. Now, so let's test this out. And let's see all things being equal. If there is no error, we should be good. All right, so I'm going to just say, okay, let's a sorted array. Let's say we have an array of age, which is 60, 61, 62, 63, 64, 65, like that, and so on and so forth. All right, so in this array, let's say I'm looking for console.log let's say I'm looking for the position of 63, for instance. So say binary search, which is your function that you've just written, and then you put in array of age, which is the age, and then you're looking for what? You're looking for any of this value. So let's say you're looking for 63, you know, so you expect it to be 0, 1, 2, 3, all things being equal. You expect it to be at index 3. So if I save that and I do this guy node mon my binary search, so all things being equal, I got 3. So to make it a bit more distance, let me say found at index, and then I have this index. Okay, so if we look at that, you can see that this is found at index 3, which looks like it's working. Let's test it one further. So let's say I increase the array size 65, 69, 88, 91. So here, save that and then look out for that. So found that index 3, yes, was because that's so let's say I'm not looking for 69. So of course 69 should be found at 0, 1, 2, 3, 4, 5, 6 at index 6, right? So you can see that's found at index 6. So pretty much this is a simple, binary search algorithm, So most important thing is just to understand it, and then you write it like that. And of course, practice made perfection. See you.